Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about introduction of natural rubber, vulcanization of natural rubber, and preparation, properties and engineering applications of Buna and Thiokol rubber. So rubber or natural rubber. So here rubber is a common name, elastomer is a technical name. So simply we says rubber like elasticity is called elastomer. Here elastomer is a technical name and rubber is a common name. So polymers with rubber like elasticity is called elastomer. Polymers rubber like elasticity is called elastomer. So technically elastomer are defined as those polymers. Technically these elastomers are defined as those polymers which are capable of being stretched at least 150% of their original length without breaking and it retains same original shape when we release the stress. This is called elastomer. So here it is defined as those polymers which are capable of being stretched at least 150% of their original length without breaking and it retains same original shape when we release the stress is known as elastomer. So here natural rubber. Generally this natural rubber which is obtained from trees like Hevia brasileus tree name. Rubber tree Hevia brasileus. So this natural rubber is obtained from trees as a latex. Latex means it is a milky white fluid. It is a milky white fluid. So natural rubber it is obtained from trees like Hevia brasileus as a latex form. It is a milky white fluid. So which is a dispersion of isoprene. So in this natural rubber it contains basic unit is isoprene. It contains basic unit is isoprene. So during the treatment of latex, so these isoprene molecules undergoes polymerization to form polyisoprene. These, for example, here this natural rubber it is obtained from Hevia brasileus like rubber trees as a latex form. So latex is a milky white fluid and it contains basic unit is isoprene. So this isoprene molecules undergoes polymerization then form polyisoprene. So that means here long coil chain of polyisoprene is formed. So this is the structure of isoprene. This is the structure of isoprene. It is also called as 2-methyl-butadiene. 2-methyl-butadiene. So this natural rubber trees when we obtain this rubber as a latex. So it containing basic unit is isoprene. So this isoprene it is also called as 2-methyl-butadiene. 2-methyl-butadiene. Where it is undergoes polymerization then form polyisoprene. So it is a long coiled chain of polyisoprene is formed. So this is a polyisoprene. Polyisoprene. Here in this we observe that in this image. So we are collecting natural rubber from this tree. This is for example here Hevia brasileus in the form of latex. So latex is a milky white fluid. Milky white fluid and it containing basic unit is isoprene. So this isoprene molecules or this isoprene undergoes polymerization then form polyisoprene. So processing of natural rubber. Processing of natural rubber. That means we collect processing of natural rubber means it involves several steps to be obtained. We are harvesting this natural rubber from the trees and converted into usable rubber products. So here processing of natural rubber means here it involves several steps to transform the raw latex. To transform the raw latex harvested from rubber trees into usable rubber products. So in this processing of natural rubber, it involves several steps. In this case, first one we obtain the rubber, natural rubber in the form of latex from the rubber trees. Then transform into usable rubber products. This is called processing of natural rubber. So in this case, its symbol first step is harvesting latex. We collect the rubber or latex from the trees. So in this process begins with the harvesting of latex from the rubber trees. Here rubber trees means, for example, Hevia brasileus. Rubber tree means here, for example, Hevia brasileus. So in this case, here we are trapped by making incisions in their bark. So what is the meaning? We are harvesting latex. That means we collect the latex or natural rubber from the trees. So in this case, we cut the rubber tree, bark of rubber trees. When we cut, it produces milky white fluid that is named as latex. So this is called harvesting of latex. We collect the rubber or latex from the rubber trees when we cutting this rubber tree to obtain latex. So here, when we cut this incisions, that means cutting, so we can tapping by making incisions in their bark. So when we cut the rubber tree, we get milky white fluid that is called latex. It is called harvesting of latex. It is the first step in this processing of natural rubber. And second one is preservation. So to prevent the latex from coagulating. So in this case, it's mixed with ammonia or other preservatives. To prevent the latex from coagulating, here it's mixed with ammonia or other preservatives. So this ensures that remains in a liquid stage during transportation and processing. This ensures that it remains in a liquid stage during transportation and processing. And third one is coagulation. So the preserved latex is then coagulated. The preserved latex is then coagulated. So this can be achieved by various methods. So the preserved, after completing the second step, the preserved latex is then coagulated. So it can be achieved by various methods such as, for example, acid coagulation. Acid coagulation. That purpose we are adding some formic acid, for example, using formic acid or acetic acid or other coagulants. Were added to this rubber. So here the coagulation process transforms the liquid latex into solid mass. During this coagulation method, we are using generally acid coagulation. For example, formic acid or acetic acid we are adding in this. So here in this process, it transforms the liquid latex into solid mass. It converted to liquid to solid mass. And fourth step is the sheet formation. Sheet formation. So here the coagulated rubber is rolled out into thin sheets. It is rolled out into thin sheets. So this can be done manually with the help of machine. It can be done manually or with the help of machines. So here coagulated sheets, in first step is we can collect the rubber sheets from the we collect the latex from the rubber trees. When we cut the rubber tree, it produces milky white fluid that is named as latex. Second one is preservation. That purpose we are adding some chemicals like ammonia or other preservatives. And third one is coagulation. So coagulation purpose generally we are using acid coagulants like formic acid or acetic acid. So in this case, liquid latex is converted to solid mass. And finally, fourth step is sheet formation. Here coagulated rubber is rolled out into the thin sheets. Rolled out into thin sheets. So this can be done manually or with the help of machines. So these sheets are hung to dry and excess water drains off. In this case, when we dry these sheets, excess of water, if in case present in this, it drains off. Next, fifth one is smoking. This step is sometimes it is optional and sometimes only it's required. So here in some cases rubber sheets are smoked over a smoky fire. We can smoke this type. Sometimes it's required this process, not necessary. It is optional process. It is optional. So in some cases rubber sheets are smoked over a smoky fire. So this process is known as smoke curing. It helps to improve the rubber color and durability. It helps to improve the rubber color and durability. So the smoke deposits carbon on the rubber, which also adds a protective layer. Which also acts a protective layer. These are the smoked rubber sheets. It is optional. Sometimes it's required. And next one is milling and mixing. So milling means the rubber sheets are then milled. That means which involves passing them through the rollers. These rubber sheets are passed through the rollers. This process is called milling. So in this case, it reduces the viscosity. It reduces the thickness of rubber sheets. You see here, milling means the rubber sheets are then milled, which involves passing them through the rollers. So rubber sheets are passed through the rollers. For what purpose? To reduce their thickness. To reduce their thickness. Then the milled rubber can then be mixed with various additives. Here milling means pass these rubber sheets through the rollers. In this case, reduce the thickness. That means viscosity. Next is rubber sheets then be mixed with various additives or chemicals depending on the intended applications. After that, we are adding some chemicals that is called mixing. So these additives might included like sulfur. Sulfur we are mixing this natural rubber for this process also known as vulcanization. So what purpose we are adding other chemicals or other ingredients to improve the properties of rubber. So in this case, sometimes you are adding additives might it's including sulfur or accelerator or an antioxidant like that, for example. And next, vulcanization. So already we know that vulcanization means a rubber is natural rubber is heating with sulfur or hydrogen sulfide or benzyl chloride. So most important is natural rubber is heating with sulfur. This process is called vulcanization. So what purpose we are adding this sulfur to natural rubber? To improve the properties of natural rubber. So which type of properties improve? So here strength, elasticity and durability. Strength, elasticity and durability. So next shaping and forming. So after vulcanization, so the rubber is shaped into desired form. After vulcanization, this rubber is shaped into desired form. This can include extrusion, molding, or any other manufacturing process necessary for the final product. So first case, it is harvesting, and second step is preservation, and third one is coagulation. Fourth one is sheet formation, smoking, and six are milling and mixing, vulcanization, shaping, and forming. So yes, smoking it is an optional process. Sometimes it's required. So in this case, it's increase the color and durability. And six are milling and mixing. Milling means these rubber sheets are passed through the rollers. So in this case, it reduces the thickness. Mixing, we are adding some chemicals or additives. So for example, here sulfur or accelerator or antioxidant etc. we are added to improve the properties of rubber. And vulcanization, it is also used for improve the properties of rubber. So in this case, natural rubber is heated with sulfur. And shaping and forming. So after vulcanization step, the rubber is shaped into desired form. Next, ninth one is quality control. So throughout the process, various quality checks are performed to ensure that rubber meets the required standards. It is important role, quality control. Quality control is the most important step in this. So throughout this processing, various quality checks are performed to ensure that the rubber meets the required standards. So this includes testing for which we can test in this quality control: tensile strength, hardness, and other properties. Tensile strength, hardness, and other properties we can check throughout this process of natural rubber. And next, packaging and distribution. Packaging on and distribution. So once the rubber is processed, and meets the quality standards, so it is packaged and distributed to manufacturer who used to make various rubber products. After process rubber sheets and after checking of quality, then it is used for to make various rubber products such as, for example, here tires, hoses, connectors, belts, gloves, and more, which are the rubber products. So this is a processing of natural rubber. It's involved total 10 steps. So all the first one is harvesting of natural rubber from the rubber trees. Then after useful rubber, then it is transferable to useful rubber products, making usable rubber products. So these are the steps involved in this processing of natural rubber. Next, what are the drawbacks of raw rubber? Drawbacks of raw rubber. So here, natural rubber, when we're collecting the rubber trees in the form of latex, then it is when we are adding coagulants or vulcanization, everything is required because improve the properties of natural rubber. Because what are the drawbacks of natural rubber? What we can improve in this vulcanization or coagulation method? So here, generally it's natural rubber. It is plastic in nature. Raw rubber and collecting from the rubber trees, it is what is the nature? Plastic in nature. That means it becomes soft at high temperature. It becomes soft at high temperature and is too brittle at low temperature. Easily brittle at low temperature. So first drawback, it is plastic in nature. At high temperature, it becomes soft. At high temperature, it becomes soft. It is easily brittle at low temperature. And it has poor strength. And it has a large water absorption capacity. So water absorption capacity also very high. And it is non-resistant to non-polar solvents. So non-polar solvents means like benzene, vegetable and mineral oils. Benzene, vegetable and mineral oils. It is non-resistant to non-polar solvents. And it is attacked by oxidizing agents. It is attacked by oxidizing agent like nitric acid, sulfuric acid, and it swells disintegrate gradually in organic solvents. And it has little durability. So these are the main drawbacks of natural rubber. So in this case, it enhances all these properties of natural rubber by using vulcanization method. So what is the meaning of vulcanization? So improve the properties of natural rubber. Improve the properties of natural rubber. So in this case, the compound with same chemicals, compound with some chemicals like sulfur, hydrogen sulfide, benzyl chloride, etc. So in this, all these chemicals, most important is addition of sulfur. In all these steps, most important is addition of sulfur. To natural rubber heated with sulfur at 100 to 140 degrees centigrade temperature. This process is called vulcanization. What purpose we are using vulcanization? To improve the properties of rubber like durability, flexibility, elasticity, nature. So all these properties improved by using this vulcanization method. So this vulcanization was first discovered by Charles Goodyear in 1839. It was first introduced by Charles Goodyear in 1839. So he observed that when rubber is heated with sulfur, at 100 to 140 degrees centigrade. At 100 to 140 degrees centigrade. So in this case, tensile strength, elasticity and resistance to swelling are increased tremendously. So which type of properties improved? Strength, elasticity, resistance with chemicals and swelling, resistance to swelling. So all these properties are improved. So in this case, when the rubber is heated with sulfur at 100 to 140 degrees centigrade temperature, here sulfur combines with chemically at the double bonds in the rubber molecule. It reacts with double bonds of the rubber spring and bringing about excellent charges into properties or resistance changes in temperature or increased elasticity, tensile strength, durability, chemical resistance. So this vulcanization process mainly used for increase the properties of natural rubber. It was introduced by Charles Goodyear in 1839. So he observed that when the natural rubber is treated with sulfur at 100 to 140 degrees centigrade temperature, so in this case, the sulfur reacts with double bonds of the rubber spring. This process is called vulcanization. So in this process, enhance the properties of rubber, like which type of properties improved. So here increase elasticity, tensile strength, durability, and chemical resistance. So this type of properties improved when we treated with sulfur. This process is called vulcanization. So here see, vulcanization means here this is a rubber chains to rubber springs. So here these are the isoprene molecules. Generally rubber contain basic unit is isoprene. So this isoprene undergoes polymerization then form polyisoprene. These are the polyisoprene chains. So this is the natural rubber. When we treat it with sulfur at 100 to 140 degrees centigrade temperature. So in this case, this sulfur combines at double bonds of the rubber spring. Double bonds of the rubber spring. So here it forms sulfur cross links. Sulfur reacts with double bonds of the rubber spring, then form cross-linking vulcanized polymer. So in this case, improve the properties of rubber. In this image, see this. So rubber is treated heating with, this is a flame, heating with sulfur. Heating with sulfur. So in this case, sulfur reacts with double bonds of the rubber spring, and this process enhance the properties like durability, elasticity, water resistance. So these properties all are increased during this process. Now let's discuss synthetic rubber. It is also named as elastomer. So here elastomer means it is a vulcanizable man-made rubber. It is also called as synthetic rubber or man-made rubber or vulcanizable man-made rubber. So here so what is the meaning of elastomer? So this rubber like polymer which can be stretched to at least twice its length. At least twice its length. But it returns its original shape and dimensions as soon as stretching force is released. So the polymer which can be stretched at least 150% of their original length without breaking, and it retains same original shape when we release the stress is known as elastomer. Is known as elastomer. So here Buna S. It is a synthetic rubber. It is also called as GRS rubber. GRS means government styrene rubber. Government styrene rubber or GRS, and also called as styrene butadiene rubber. Styrene butadiene rubber. So it is probably the most important type of synthetic rubber. Buna is a most important type of synthetic rubber. So how can you prepare this synthetic rubber? Buna is, which is produced by copolymerization of two or more monomers. Undergoes polymerization. That is called copolymerization. Two or more monomers undergoes polymerization, then form polymer. This process is called copolymerization. So how can you prepare this Buna S or styrene butadiene rubber? So copolymerization of butadiene. Copolymerization of butadiene and styrene. Here Bu stands for butadiene, sodium stands Na stands for sodium. Here it acts as a catalyst. S stands for styrene. Butadiene, styrene. And here sodium acts as a catalyst. So here 70% by weight of butadiene and styrene 25% by weight of styrene undergoes copolymerization, then gives Buna is butadiene styrene rubber or GRS rubber. Here from Bu stands for butadiene and Na stands for sodium. Here it acts as a catalyst in early days of its synthesis, and S for styrene. It stands for styrene. So it's the synthesis reaction of Buna S. So butadiene styrene rubber, it is the best example of synthetic rubber. Here how can it form? How can you prepare this Buna S? Butadiene. Buta means 4 carbons present in this, and diene, 2 double bonds present in it. 1, 2. So butadiene, 75% by weight of butadiene, and styrene, 25% by weight of styrene. Undergoes which type of polymerization? Copolymerization. Undergoes copolymerization. Then gives Buna S. Butadiene styrene rubber, or it is also called as GRS rubber. It is also called as government styrene rubber. So what are the properties of Buna S? So it has good abrasion resistance. It has good abrasion resistance. So that means it's excellent abrasion resistance. It's excellent abrasion resistance, making it suitable for use in tires. This generally Buna is having good abrasion resistance. So that's why it is suitable for use in tires, making tires. And also conveyor belts and other applications that require resistance to wear and friction. Resistance to wear and friction. And second one is excellent flexibility. Excellent flexibility. So it has good flexibility. Bunais has good flexibility. So which allows to be used in various applications where the materials need to be bent or stretched without cracking. Without cracking. So it has good excellent flexibility. And third one is high tensile strength. High tensile strength. So Bunais has high tensile strength. So which means it can withstand stretching forces without breaking. Without breaking. So this property is beneficial in tire manufacturing. Most suitable for tire manufacturing. And next, good weather resistance. So Buna has moderate resistance to weathering, ozone and ultraviolet radiation. Ozone and ultraviolet radiation. So which make it suitable for outdoor applications like gaskets, seals and hoses. Hoses means connectors. And next, water resistance. Buna it is having good water resistance also. So it is generally resistant to water and moisture. So making it suitable for use in applications that involve contact with liquids. It has high water resistance also. And electrical insulation. So Buna S can serve in electrical insulator, which is useful in applications of whether electrical conductivity must be avoided. It acts as a good electrical insulator. Discuss applications of Buna S rubber. So major application of Buna or butadiene styrene rubber is manufacturing of tires. Main application of this Buna rubber used for making of or manufacturing of tires. So Buna is a major component in manufacturing of automotive and bicycle tires due to its abrasion resistance and flexibility. So just now we discussed already, Buna it is having high abrasion resistance and flexibility nature. So that's why we preferred for manufacturing of tires and also used in automotive and bicycle tire manufacturing purpose we are using. And it is also used in footwear industry. It is also used in footwear industries for making shoe soles and footwear components because of its durability and flexibility. Because of durability and flexibility. That's why mostly we preferred in footwear industry. And third one is it is also used for making wires and cables and insulators. See this image. Here we are using footwear industries, automobile industries, making for tires and connectors. And it is used for making wires, cables, connectors because it acts as a good insulator. And it is also used for production of floor files, tank linings, chemical industries. Also used in lining in chemical industries. And Buna is employed in the production of gaskets, seals, and also providing a good balance of flexibility and resistance to environmental factors. So these are the applications of butadiene styrene rubber, mainly used in manufacturing of tires and also used in automotive bicycle tires manufacturing purpose. We are using because of they are having high water absorption, abrasion resistance, and flexibility, and also used in footwear industry because they are having Buna is having high durability and flexibility, and it acts as a good insulator. That's why I use it for making wires, cables, connectors, etc. Next, we'll discuss Thiokol rubber. It is also most important synthetic rubber and it is a unvulcanized rubber. It is also a synthetic rubber, man-made rubber. So it is also called as polysulfide rubber. Polysulfide rubber and also called GRP rubber. Government polysulfide rubber. So it is prepared by condensation polymerization of. Condensation polymerization means it is formed by two different functional group of monomers. It is formed by two different functional group of monomers. So undergoes polymerization and it forms new functional group of polymer. A new functional group of product polymer is formed and eliminating byproduct. The process is called condensation polymerization. Here Thiokol rubber also prepared by condensation polymerization of 1,2 dichloroethane 1,2 dichloroethane and sodium polysulfide sodium polysulfide. So it is prepared by condensation polymerization of sodium polysulfide and ethylene dichloride. Ethylene dichloride. So in this elastomer, sulfur forms a part of the polymer chain. So this Thiokol rubber, it is also called as polysulfide rubber. It is prepared by condensation polymerization of sodium polysulfide and 1,2 dichloroethane. It undergoes condensation polymerization. Condensation polymerization. Then it forms Thiokol rubber. It forms Thiokol rubber. It is also called as ethylene polysulfide rubber. Ethylene polysulfide rubber. It is an unvulcanized rubber because there is no rubber springs. So what is the vulcanization process? When natural rubber heated with sulfur, the sulfur mainly reacts with double bonds of the rubber spring. So in the rubber manufacture, it contains double bond. In this case, only vulcanization is possible. But in this Thiokol rubber, there is no double bonds. So it is an unvulcanized rubber, but it is having good properties. So it is prepared by 1,2 dichloroethane and sodium polysulfide undergoes condensation polymerization, then form Thiokol rubber. It is also called as ethylene polysulfide rubber and in this elimination byproduct is sodium chloride. It's a preparation of Thiokol rubber. Next, properties of Thiokol rubber. So it has chemical resistance. It has chemical resistance. So Thiokol rubber exhibits outstanding resistance. Outstanding resistance to a wide range of chemicals. Wide range of chemicals including acids, bases, solvents and other fuels. So this make it highly suitable for application where exposure to corrosive substance in a concern. So it has high chemical resistance. And next one is low temperature flexibility. Low temperature flexibility. So this Thiokol rubber remains flexible and resilient at extremely low temperature. So this Thiokol rubber it remains flexible and resilient at extremely low temperature. So often down around minus 50 degrees centigrade. Minus 50 degrees centigrade. So this property is advantageous in cold climates and aerospace applications is most suitable this type of rubber. Aerospace applications in that more suitable this Thiokol rubber. And heat resistance. So it also had good heat resistance with standing temperature up to approximately 121 degrees centigrade temperature. So this make it suitable for applications involving exposure to high temperature. It is more suitable also. In cold weather also it's suitable and high temperature also it's suitable. And oxygen ozone resistance. So this Thiokol rubber is known for its resistance to oxygen and ozone. So which make it suitable for aerospace application. It has high resistance with oxygen and ozone resistance. So it makes it suitable for aerospace applications where exposure to these elements is common. Next, electrical insulation. It has electrical insulating properties and can be used in applications that require electrical insulation. It acts as a good electrical insulator. And next, tensile strength and tear resistance. So Thiokol rubber has good tensile strength and tear resistance. So which allows to withstand mechanical stress and wear. Allows to withstand mechanical stress and wear. And next, flexibility. So it maintains flexibility over a wide temperature range, which is important for various industrial and aerospace applications. So where we can use, what are the uses of Thiokol rubber? So we can use aerospace sealants. Aerospace sealants. So Thiokol rubber is commonly used in aerospace industry. It is commonly used in aerospace industry for its ability to create airtight seals in critical applications such as rocket engines, fuel tanks, and aircraft fuel systems. So it is most suitable and it is used in this aircraft industry, airspace industry, and military and defense applications also we are using this Thiokol rubber. So this Thiokol rubber is used in military equipment and military vehicles where its chemical resistance, fuel resistance, and extreme temperature performance are highly valuable. So this Thiokol rubber is mainly used in aerospace industry and also we can use military vehicles, defense application purpose also we are using this Thiokol rubber. And next, adhesives and sealant. This Thiokol rubber is used as a adhesive and sealant. So it is used in adhesives and sealant for various applications. So it's including construction of tanks. In the applications, it's including construction of tanks, pipelines, and other chemical storage and transport systems. So the Thiokol rubber used as a adhesive and sealants. So it's including, for example, construction of tanks, pipelines, and other chemical storage and transport systems. And next one is marine applications. So Thiokol rubber can be found in marine sealants and gaskets. So as it withstands exposure to salt water and marine environment. So in this case, marine applications also we prefer this Thiokol rubber. And oil and gas industry. So it is used for seals. It is used as a sealing agent. So it is used for seals, gaskets, and other components in the oil and gas industry. So particularly in application involving contact with hydrocarbons and chemicals. So you see this image, see the balance made up of this Thiokol rockets and also used in airspace industry, military vehicles, military and defense applications. And it is used as a adhesive and sealant. It is also used in marine applications and also used in oil and gas industry also. This Thiokol rubber. So in this session, we learned about what is natural rubber, what are the drawbacks of natural rubber, processing of natural rubber, what are the steps involved in this processing of natural rubber, how can we harvest this latex rubber from the trees and then transformed into usable rubber products. So what are the steps involved in this processing of natural rubber? And we discussed already synthetic rubber. In this we discussed about synthesis, preparation, properties, uses of Buna and Thiokol rubber. I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.